Greetings, this is Mr. Garwood with our continuing video series on Calculus 2nd edition by Briggs, Cochran, and Gillette. In our previous video on trig definitions, I focused on showing you the limit definition rule, proving that the derivative of sine is cosine and the derivative of cosine is negative sine. My goal in this video is, using the product rule, quotient rule, and some of the other tricks we have learned thus far, show you where these other four come from. I'm going to jump right in because I'm really afraid this video is going to take up a lot more time than I care to admit it does. So, I'm going to start with tangent. So I want the derivative with respect to x of tangent x. Now, to do this, I'm going to be a little tricksy. If you remember, tangent is actually sine of x over cosine of x. And what I'm going to do is I'm actually going to evaluate this using the fact that sine and cosine have the derivatives we developed. And I am going to use the quotient rule to solve this. So the quotient rule, if you remember that stupid little jingle I went, is low d high minus high d low over the square of what's below. So this would be, low d high would be cosine x times the derivative of sine x, which is also cosine x. And then I'm going to subtract high d low, so high is sine x, and the derivative of the bottom is negative sine x, all over cosine squared. And I don't know why I did that in black. I meant to do that in green. I keep doing that, in fact. Now, what's going to happen here is I now have cosine squared plus sine squared over cosine squared. If we remember our trig identities from pre-calc, cos squared plus sine squared is 1.
Attention all students. If you're riding the after-school bus, please report to room 209 today. Attention all students riding the after-school buses, please report to room 209. Thank you.
The joys of trying to record videos after school. So, I've got 1 over cosine squared. Now, if I'm careful here, I can actually write this as 1 over cosine squared. Cosine squared, well, that's still fine. 1 over cosine x quantity squared. Now, 1 over cosine is the definition of secant. Secant is the reciprocal of cosine. So, the derivative of tangent is secant squared x. So I'm going to come back to our definitions here. Derivative of tangent is secant squared x. So there's 1, 3 to go. Okay. So number 2, the derivative of cosecant x. Now I have to use, just like I did, the derivative of cosecant x is really the derivative of 1 over sine of x. Now, let's go ahead and make this colorful so it's easier to see. So I'm going to say sine x on bottom. Let's see if I can actually do all my bottoms in green this time. And 1 on top. Now, low d high, so that's sine x times the derivative of 0, or of 1, which is 0, minus high, so that's 1, times the derivative of sine, which is cosine x, over sine squared x. Apologize, I'm actually pulling out my book to make sure that I'm doing this correctly, because these can be kind of crazy. Table of integrals. Where's my table of derivatives? All right, sorry about that. Now, on top, I now have, this term is 0, so I'm left with on top negative cosine x over sine squared x. Now, through a little trickeration, I'm going to say that is negative cosine x over sine x times 1 over sine x. This is cotangent, so I have negative cotangent x times, and the reciprocal of sine is cosecant x. So there's our next one, and I can't simplify that anymore. This is negative cotangent x cosecant x. And you might see those flips, but it doesn't really matter. All right, so there's tangent and cosecant. So up next we'll do secant. So the derivative with respect to x of secant x is the derivative with respect to x of 1 over cosine x, because secant is the reciprocal of cosine. Doing the same thing, I have cos x times the derivative of 1, which is 0, minus 1 times the derivative of cosine, which is negative sine x, and that is over cos squared x. Notice this one and cosecant have a lot of similarities. Just like before, you got negative 1 times negative sine, which is, because this is 0. I have sine x over cos squared x, which is sine x over cos x times 1 over cos x. This term is tangent. Sine over cosine is tangent. This is secant. So that means my derivative of secant is tangent x secant x. All right, we've got one more to go. That's going to be cotangent. So the derivative with respect to x of cotangent x is the derivative with respect to x. Now cotangent is cos over sine. It is the reciprocal of tangent. So that is cos x over sine x. Okay, so that is the derivative with respect to x of sine x times the derivative of cosine, which is negative sine x, minus this is cos x times the derivative of sine, which is cos x, over sine squared x. So negative sine times sine, or this goes away, sorry. I have negative sine squared x minus cos squared x all over sine squared x. Now, I'm going to factor out a negative 1, so I've got negative 1 times sine squared plus cos squared all over sine squared. Now, if we go back, sine squared plus cos squared is 1, so I have negative 1 over sine squared x. Sine squared x can be rewritten as 1 over sine x squared. This is cosecant, so I have negative cosecant squared x. So we can now finish out our table. So this is negative cosecant squared x. And there are our 4 trig identities and where they come from using the product rule and the quotient rule. Actually here it's all quotient rule, which is why I had to show you it in 3.5 before I could show you trigs in 3.6. I hope that you have found this video useful. Good luck as our semester continues.